guys, so in this last video, all I do is take everything we've learned, put it all together, and show you how to just basically deal with one quadratic function using all of the things that we've just talked about, how to graph it, okay? So if you understand what we've done so far, great. If you want to just see it play all out in action, take a look at this video. Okay, so now let's put it all together, you guys. We learned so much about graphing quadratic functions today and all these little pieces of very important information. So right, when we have a quadratic function of the form ax squared plus bx plus c, which we have right here, y equals x squared minus 10x plus 19, the first thing you should always do is figure out your coefficients a, b, and c, right? So here we have a coefficient of a equals 1, b equals negative 10, and c equals 19. All right, we learned that the graphs of these parabolas can either be concave up or concave down, and that depends on whatever the value of your a coefficient is. So if your a coefficient is positive, like with this graph, your graph is concave up, right? It's making that nice U shape. If we had had a negative a, our graph would have been concave down. All right, the concavity of our graph also tells us whether or not we're dealing with a minimum or a maximum. So since our graph is concave up, we are dealing with a minimum, right? That lowest point there, which is the vertex, all right? Your vertex will either be a minimum or a maximum. Since our graph is concave up, our vertex is a minimum. For our graph, our vertex is 5, negative 6, and we found that by first finding the x value, which was equal to negative b over 2a. That gave us 5. And then we plugged in that 5 to our function, x squared minus 10x plus 19, right? Everywhere we saw an x, we plugged in 5, which gave us negative 6, okay? So that's how we figured out the ordered pair for our vertex. We also talked about something called the axis of symmetry, which is just the line that goes through your vertex. It's the line that cuts your parabola in half. So for our graph, our axis of symmetry was the line x equals 5. Okay, that line goes through our vertex, so you'll notice x equals 5. It's the same value as our x value of our vertex, okay? And it's just cutting our parabola right in half. We then talked about the y-intercept. The y-intercept is just the point 0, c, okay? So if you know what your value of c is, you also know your y-intercept, okay? For our graph, it's 0, 19, because 19 is our value of c, which means it's going to hit our y-axis up here at 19, 0, 19, okay? And then we talked about, of course, x-intercepts. We know that quadratic functions can have either 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. This particular parabola has 2 x-intercepts. There they are. Okay, and how did we find them? We used the quadratic formula, which says that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided all over 2a, right? That will give us our x value. And of course, our y value is 0 because we're dealing with x-intercepts here. Okay, so that is graphing quadratic functions. I hope this was helpful. And if you have any questions, please always reach out. I am here. All right, you guys, take care. Goodbye.